Relating fractions to decimals. All fractions can be represented as decimals because both of them are a way to represent part of a whole. So we're going to go through 6 common fractions and their equivalent decimals, but by the end you should be able to know how to translate any fraction into a decimal, not just these 6. So let's start with the easiest one, 1/2. Its equivalent decimal is 5/10. For each decimal, for each fraction, I'm going to give you a strategy, something to think about so that you don't have to just memorize them. So for 1/2, let's think about money. If 2 people share $1, then each person will get 50 cents. And we know that 50 hundredths, you can just take away the 0, is the same as 5/10. So looking at that at a 100 grid or base 10 blocks, we can see that if we divide the flat in half, we would have 5/10 or 5 rods on this side. So 1/2 of the 100 grid would be 5/10. For each of these fractions, I'm also going to show you how to use this equivalency to figure out how much other fractions are worth. So for example here, 3 1/2 would be the same as $3 and 1/2 of a dollar, or 3 5/10. 5/2 would be the same as 5 of 50 cents, 5 times 5/10, which would give you 2 5/10. The next one to think about is the 1/4 fraction, which is equal to 25 hundredths. Again, let's think about money. Think about one person, $1 split among 4 people. And if we take $1 and split it into 4 people, each person is going to get 25 cents or 25 hundredths. Here it is in the base 10 blocks in the 100 grid. You can see that the square has been divided into 4 sections, 1, 2, 3, 4, and if one of those is colored in, then it's 25 small boxes, see, 5 times 5, which is 25 hundredths. Here, let's think of some other fractions that would have that would be broken into fourths. 3/4 is like 3/4 or 75 cents. This is going to be one that's worth memorizing because you're going to see it so often. 1 1/4 is like $1 and 25 cents, which is 1 25 hundredths. And you might even see an improper fraction, 9/4, which would be 9/4. If I had to do mental math and think about this in my head, I know that 8/4 is $2. So that would give us $2, and we'd have 1/4 left over because we have 9, $2.25, or 2 25 hundredths. The next one is eighths. 1/8 is equal to 0 and 125 thousandths. Again, the best way I think to think about this is money. Think about half of a quarter. Now I know that's not a real amount, but it's the closest way to think about, the easiest way for me to think about. First of all, you have to know that 1/8 is half of 1/4. Here is 1/4, and 1/8 is half of that. So 1/8 would be half of a quarter. So if I take this quarter here and break it into 2 pieces, first I would give each person 10 cents, and then I would have 5 pennies left over. So I'd give each person 2 pennies, and then I'd have 1 penny left over. And so it's like you'd have to think about splitting it in half. So if you split a quarter in half, each person would get 12 1/2 cents, which here's the 12 cents, and we would show the half of a penny in the thousandth place. So looking at this grid, you have to think about it this whole 100 square, the flat, being broken up into 8 pieces. So this would be 1 piece, the next 8th would be here, 2 more 8ths. So if we divided this whole thing into 8 pieces, this is how much of it would be colored in. Here are the 10, 11, 12 hundredths, and then there are the 5 thousandths that come right here. So if we think about 3/8, we would do 3 times this amount, the amount for 1/8, and get 0 and 375 thousandths. 7/8, we would do the same thing, multiply 7 times the amount for 1/8, and we would get 0 and 875 thousandths. 1 1/8 would be like $1 and 1/2 quarter, which would be 1 and 125 thousandths. The next one is 1/10, and it's equal to the decimal 1/10. This one is sort of an obvious one. The easiest way that I know is to just read it out loud. You can also, and by that I mean that 1/10, the fraction, you read the same as a decimal, 1/10. You can also think about it like money, though. It still makes sense. If 10 people share $1, each person is going to get 1 dime, and 1 dime is equal to 10 hundredths, which is the same as 1/10. Here you can see that the flat is divided into 10 pieces, and we call one piece a tenth. And each of these you can just think about how we read them in decimals and fractions. 3/10, the fraction, reads the same as 3/10 the decimal. 9/10, 9/10. 1 and 7/10, we read it the exact same way in a decimal. 1 and 7/10. Next, let's think about 1/5. The fraction 1/5 is equal to 2/10. The easiest way that I think to think about 1/5 is to change it into tenths, an equivalent fraction that's written in tenths. So I've done that here. 1/5 multiplied by the 1 whole fraction 2/2 becomes 2/10, which is then an easy fraction to hear and write as a decimal 2/10. You can also think about it like money, though. If you think about 5 people sharing $1, each person would get 2 dimes, which is equal to 20 cents or 2/10. Here in the flat, we can see that the flat has been divided into 5 pieces, 1, 2, 3, 4, 5, to represent fifths, and then one of those fifths is equivalent to 2/10 or 2 rods. So down here we can see 2/5 would be 2 times the amount of 1/5, 2/10, for a product of 4/10, but you can also change it into tenths. 2/5 multiplied by a 1 whole fraction gives you 4/10 as an equivalent fraction. So 4/10 the fraction we can easily write as 4/10 the decimal. Here I changed this one into tenths as well. 1 and 4/5 by multiplying by 2/2 is 1 and 8/10. Those are equivalent fractions. And 1 and 8/10, the fraction, you can write as 1 and 8/10 the decimal. Finally, we have 1/12, which is written as 0 and 83 thousandths with the 3 repeating. There's going to be some fractions that we get to that we can't think about money, but there's really no way to make sense out of it, and the only way to turn it into a decimal is to think about it like a division problem, and I think that 12th is a good example of that. So 1/12 you can write as 1 divided by 12, and in order to solve that, you would want to ask Decimal Dog to spit up a 0 and a decimal. And so now we can think about it like 12 going into 100. But let's go ahead and put our decimal point in the right place. All right, 12 can't go into 1. 12 can't go into 10. But 12 can go into 100 8 times. 8 times 12 is 96. 100 minus 96 is 4. Now I'm not quite done. I don't want to have a remainder, so I'm going to put another 0 there, which is still an equivalent decimal. I'm going to bring down that 0. 12 goes into 43 times. 3 times 12 is 36. And I'm going to get 4. And if I continue and continue and continue, I'm just going to keep ending up with 36. 40 minus 36 is 4. So over and over and over, I'm going to get 3's in this decimal. We shorten that like this. We show just the part that's repeating with a line over it like this. So this decimal over here, you can see in the hundredths grid that it's showing 8 hundredths here, and then a third basically of 1 more hundredth. So 3 pieces of this one if we broke it up into 10 pieces. If we wanted to make sure that that makes sense, we can do it this way. 1/12 we know is less than 1/10 because a bigger denominator means a smaller piece. So 1/12 should be a little bit less than the decimal equivalent of this. And that is true. This is a little bit less than 1/10. So if we have another 12th, another fraction with 12 as the denominator, 7/12, we can figure out its equivalent decimal by doing the division problem, 7 divided by 12. And I got 0 and 583 thousandths with the 3 repeating. And to check it, to make sure that it makes sense, I know that 7/12 is a little bit bigger than 1/2 because 6/12 would be 1/2. So 7/12 should be just a little bit bigger than 5/10, which it is. This is a little bit bigger than 5/10. So you can use this division problem for 12ths, but you can also use it for any other fraction that you come up on that you don't know its equivalent decimal.